In this lesson we're going to look at a typical refraction problem in which we have to find the angle of refraction of a beam of light that's incident on a glass block. So for example, let's imagine we've got a laser beam of red light which is incident at this surface at an angle of 45 degrees. So this is the normal to the surface, and as the beam passes across the boundary it's refracted by the glass block, and we have to calculate this angle of refraction. So the first thing we're going to do is write out Snell's Law. Now in this case it's for a beam that's passing from air into glass. Right, and we write the refractive index is equal to the sine of the angle of incidence divided by the sine of the angle of refraction. Now in the case where the beam is exiting the glass block, that's to say it's going from the glass into air, then Snell's law then becomes n is equal to the sine of the angle of refraction divided by the sine of the angle of incidence. So if the beam were going from the glass into the air, then we would write n is equal to the sine of the angle of refraction divided by the sine of the angle of incidence if it were going from glass into air. Okay, but we're not in this case, so I'll remove that. Now then, what we're after is the angle of refraction, so we've got to play around with this equation, so we have the sine of the angle of refraction on this side of the equal sign. Now if you're not very happy about playing around with equations, then I suggest you use a calculation triangle, and these are used normally to help us with equations that involve three variables. And if our expression is written in the form something is equal to something divided by something, then the something divided by something slots into the triangle here. Alright, so we've got the division bar, and we write sine of I, sine of the angle of incidence, divided by the sine of the angle of refraction, and then the third term, in this case which is n, slots in here. Alright, now the term that we're after here is the sine of r. We know I and we know n. So what we'll do is we cover up the term that we're after, and that leaves us with the sine of I divided by n. So we can write the equation now in terms of the sine of the angle of refraction. And that's equal to the sine of the angle of incidence divided by n. And so all we have to do now is slot the values into the equation. So we have the angle of incidence, I, is equal to 45 degrees. So we have sine of 45 degrees divided by 1.52, which gives us 0.707 divided by 1.52. So I'll get my calculator out. I've got my scientific calculator from Windows. 7 divided by 1.52 equals, so the answer is 0.456. So it's always a good idea to round off these signs to 3 places of decimal. Now I'm not after the sine of r, I want to find r itself. I want to find the angle of refraction, not the sine of the angle of refraction. So I've got to make one more step here to find the value of r. And to do this we need to use a different function on the calculator called the inverse sine. So I need to find the inverse sine of this value, right, which is sine to the -1. This -1 means inverse sine of 0.456. Let's get the calculator back. So 0.456, type in the number, and then you click on the inverse button and then choose sine to the -1, this one, and that gives us the angle, which is 27.129. round that off to 2 places of decimal, 27.13. R equals 27.13 degrees, and there you've calculated your angle of refraction.